everybody. Good to talk to you today. Today I want to go over some trends in GenAI development that we're seeing from Docker's perspective. First, quick little intro about me so you know who's on the stage. I'm the VP of Product for Docker Hub, and I'm VP of Product. I transitioned to that role from being an engineer for a really long time, academic background, computer science, and I really made that transition with a focus on building developer tools. So basically just building products for myself. And when I'm not doing the whole product thing, I like to swim, bike, and run in that order. So if anyone likes to do triathlons, I'd love to talk to you about it. I said I was the VP of product over Docker Hub, right? So what is Docker Hub, just so everybody knows what we're talking about? This is the central registry where pretty much every open source dependency for containers is housed, and pretty much every developer in the world pulls those containers from into their stacks. And it's a pretty privileged position to be at to run product for it, because I get to see what's happening in the development community for the adoption of different tools as they're starting to happen. And that's what sort of leads me into this talk about one of the trends that has clearly been happening when you look at all the stats from Docker Hub is that application developers across the world are starting to use AI tools more and more in their daily lives, right, in their local development. So this is a graph that shows what we call Docker pulls, right? It's essentially whenever a developer downloads an image for use in their inner loop or in their CI environment or maybe in production in a Kubernetes cluster. And what we see when we look at the data just over the past 6 months is that there's been a massive growth in Docker pulls for AI-related images. These are things like inference engines, vector DBs, testing and observability tools, and it's been this just massive 130% growth rate. That's quite different than the growth rate of other types of images in Hub, like databases and messaging queues. Those generally rise at a 20 to 30% rate, and that's kind of correlated with the adoption of containers overall. And so the question I ask is, why are we starting to see this now? And I think it really comes down to a change in persona of who's starting to use these tools in their daily life and what kind of applications are being built. These are some of our internal personas that, as any good product organization uses to try to build products that help these people. And we're seeing a real shift from the data science persona, who was the one tasked with understanding GenAI models and using them, over now to the application developers, who are starting to, the full stack engineers, the software engineers now being tasked to build applications using that at scale. And I think that that's where this shift is happening, because that's who comes to Docker Hub, our application developers every day. A helpful comparison to make, to understand this technology trend, is actually by looking at the mobile app development trend, one of the last major big trends that tech shifts that happened years ago, over a decade ago. This graph is just the chart of the rise in mobile apps in the App Store, right? To just kind of correlate the growth of that application development. But over the span of 10 plus years, you saw massive growth, whole new industries being built based on that technology shift. And I really think that we're just at the beginning of this, right? With the launch of GPT just under 2 years ago, ChatGPT under 2 years ago. But a lot changed during that 10-year period, right? You had big companies fail to take advantage of the trend. I'm sure everybody maybe remembers the interview with Bill Gates and Steve Jobs, where Microsoft said that nobody's going to want a computer in their pocket. Pretty sure we know who was right there. We saw device proliferation, a lot of different hardware, a lot of different mobile phones coming out. Maybe some of you remember the Fire phone. Maybe some of you don't. The battle between closed source and open source, right? Closed community ecosystem, Apple, open community with Android, and how that spawned many other operating systems to be built on top of it. And you also saw new programming languages being built. Swift came out, right, for Apple. And then brand new user applications were built over that time span. And that was, you got new experiences being built that you would have never thought to exist at the beginning of this trend. I doubt at that time anyone would have thought that you'd be ordering a taxi on your phone, right? And so the point is that we're really just at the beginning of this major transformation. But I think what we're seeing is it happening much faster than previous transformations. Pretty much like every tech shift happens, right? You learn from the past and you apply those learnings into the future. So what are some of those trends that we're starting to see? So in the span, remember, we're only in the 2-year period. We're in less than 2 years where this has been a trend. The first trend we're starting to see is paid-for models, right? Paid-for models like ChatGPT and Cloud and others. And they're all very API-driven, right? Been massively adopted because of how easy they are to use, invoke with an API. But they are black boxes, right? You don't actually get to understand what's going on behind the scenes. That can be somewhat good for getting started, but it's also a great way to increase costs because you just can't optimize it. At the same time, we're starting to see the open source ecosystem grow and take off, I think, a lot sooner than we saw in the mobile trend. So you have like Meta really leading the charge here with Llama. I mean, you can maybe in quotes open source, but Mistral as well as others. There's also been a large increase in the number of inference runtimes that you see that are available to use. So that ecosystem just growing with Llama, VLLM, and a really interesting trend is the rise of developer tooling. You see orchestration tools, logging, observability, testing. That definitely wasn't the case before with like other trends like mobile app development. We're learning from that trend and applying it here. And then I think the final set of trends really is new development patterns or architectural patterns that we're starting to see emerge. So you can already see the debate between which way is the best way to use a model. Should you use a RAG stack? Should you have long context windows? Should you be fine-tuning models? Companies across the world, engineers across the world are having this debate. It's a healthy debate. The answer is probably yes to all of them, and it just depends on the use case. Local host is the thing, right? It wasn't at first, but now it's definitely the case that you can run these things locally in lower environments, and developers are starting to run them themselves. And then one of the newer patterns that I think we're starting to see emerge, that I'm going to spend the rest of the talk today going over, is the creation of a new architecture that is dubbed agentic AI workflows, right? A fancy name. But I think that's one of the patterns that I've become most interested in because it creates like brand new ways to think about how to build systems that accomplish the ultimate task that it's trying to do. So I'm going to go over this for the rest of the talk. Here's a depiction, here's like a visualization of the basics of an agentic AI workflow. So there's two actors. You've got your code, right? And then you've got the large language model on one side. And essentially what's happening is the code is registering functions, or what are referred to as tools, with the model and giving it some context about when it should call the tool and so that it knows what to respond to based on the prompt. So the code will send in that extra context about registering the functions. You send in a prompt. The large language model is understanding your prompt. And then it returns back to the code, hey, you should call this function, right? I need you to call this function first. And then I'm going to take the response of that function. The client returns that to the large language model, gets added in the context, and then it continues on until it completes the prompt that you said that you wanted it to do. So it's a really complex name for a pretty simple concept, but I think it leads to some powerful outcomes for what can be built. And this is what really we've been exploring at Docker is how to use these types of architectures to understand what application developers are building. And so we launched this initiative called Docker GenAI Labs beginning of the year. And through this project, we've been sort of exploring the boundaries of what's possible with GenAI and how can we help the development community adopt these architecture patterns. It's become essentially a set of blog posts, sample code, Visual Studio Code extensions, desktop extensions, and again, just really exploring the boundaries of what's possible. So within this initiative, there's a lot of mini projects, right, that are being explored. They're almost like missions that we go on to understand, can a GenAI application complete this task? One mission that we went on was to see if we could have a GenAI application using this agentic AI workflow actually generate a usable Dockerfile without a human in the middle, right? So normally when you're using some kind of chatbot, you're just interacting with the large language model and you're trying to get something useful out of it. Like if I go ask ChatGPT to give me a Dockerfile, it'll give me one. I just can't really use it. I have to go and manipulate it, and I might as well not have asked it to begin with. So we wanted to see if we could make it something very usable, something that would have your best practices in it so that you can actually use it. So to do this, we started with this architecture, right? This is like a high-level architecture of how this works. So on the left here, you've got the registration of some tools, right? These are functions like write a file or analyze a project, right? I want to know what kind of project I'm building a Dockerfile for. And then there's also a function in here for recommending, for getting a scout recommendation, which I'll talk about a little later. Those are created as functions that are encapsulated in a Docker container and registered with the large language model. And then you've got your large language model, right? You've got a model. It can be any model that's really open AI, API compliant, has this capability. Then you've got system prompts. These are really important because they encapsulate your domain expertise for the large language model to produce something useful on the outside, on the output. You have a project, like the actual code that you want to generate a Docker file for, and then the client. All the client's really doing is starting putting the first domino down, and then removing itself and allowing the model and the tools to just complete the output without the human in the loop. So how this ends up working is actually like a conversation between two computers, right? The large language model and your functions. So I thought it'd be fun to walk through that conversation step by step and see what the output looks like. So the first part of the conversation is inserting a system prompt into the model, right? You have to give it a personality. And here we're saying you're an expert and you should be really confident in your responses when you generate a Docker file. So it's an important personality to have if this is the kind of task that we want the model to do. Then the client issues a prompt, right? And this is the prompt that essentially is used to start the agentic AI workflow that says, I want a Docker file. But a really important thing to realize here is that it's broken down the problem. We've broken down the prompt into two steps, right? Normally you would think about this problem as just write a Docker file, but we have to actually decompose that problem into smaller steps, right? What do you normally do? You actually analyze the project, you figure out what kind of project it is, and then you write a Docker file. So decomposition is actually a really important part of thinking in this way, and so are even those tools that you registered around the writing the file and the different steps that you're taking. So keep going on. With that prompt in mind, and the registration of those tools already happening, the model returns back a function call, essentially. It says, okay, in order for me to complete this task you want me to do, I need to analyze the project. So it tells the client to call the function analyze project. And the function is called, it returns back a response that says it's an NPM project, right? It just looks for node modules and some other various NPM related files. And so that gets returned back to the model, and we move on with the conversation. And here, as part of that return of the function, it's also providing more system prompts. So more additional context to the model so that it can actually understand what the best practices are for writing a Docker file. So I'm going to go into this a little more because it's actually worth expanding into. So the full version of that system prompt is what's on the screen here. And there's some really key things in this, right? What you're looking at is really a text file that's committed to source, that's committed to the tool's source code. It's the encapsulation of your knowledge, of your best practices. It has things in here like how to use multi-stage builds, what are the best parameters to use to optimize the build process. In the middle there, you can see things around what it means to make a recommendation from the Scout tool. And Scout is a Docker product that allows you to understand the security posture of dependencies and help you pick the one that is most secure. It even has if statements in there about, if you're going to do this in the Dockerfile, then here's a couple more optimizations to do. And so what I really take away from this system prompt is it's a way to encapsulate all your domain knowledge in code, in source code, so that the output of these models becomes actually useful. And this is ours. This is our best practices. Yours might be different. So you'll be able to personalize these models with your own system prompts. Okay, so let's go back to the conversation. So we gave it all that context about how to generate really good Docker files. And then it returns back with that function, another function call, right? It says, look, I think I'm going to need that scout function call to be made. So it makes the scout function call, returns back the appropriate tag to use based on what that function does. It basically just calls some of our APIs to get a recommended tag. That gets returned back to the model. And now the model says, I'm ready to generate the file. And it's essentially making another function call to write the file. But within it, it's got the contents of the file as input to that function, and that's getting sent back to the client to try to write the file. But unfortunately, there was an error in the contents of the file. It had a sort of a standard syntax error for the JSON that it couldn't write the file. So you think the conversation would be done now, right? The model called the tool. Tool said it returned back with an error. Oh, well, maybe we can't do this. But in fact, what happens is pretty interesting. So that response, that error code, gets sent back to the model, right? It says, I failed. And so then the model returns back with an interesting prompt. It says, OK, look, I'm sorry. I didn't mean to make an error. How about try this again? Try this other file again. And it fixes the syntax error. And it returns back with another file to write again. This time it's successful, right? It says, OK, it was able to call the write function successfully and return back the successful response to the model. So this is another important key takeaway, right? I take away two things from this interaction. It's kind of simple, but actually can be pretty powerful. First, these function calls are going to fail, right? This is a very simple model or a simple interaction, but you can imagine these function calls doing more and more complex things. You want to really sandbox those function calls so that the blast radius of an error is contained. But also reliability is key, right? You've got all these systems interacting with each other who need to make the calls successful. They need to be executed reliably. So making sure that workflow it's essentially a workflow, is being executed reliably is really important. But OK, so the file was written, and that gets returned back to the model, and the model says, OK, I'm done. It realizes that it was able to accomplish the task that you said it was supposed to do. And it returns back this response. And we completed the mission, essentially. So some key takeaways from going through this example. The first was that the prompts encapsulated knowledge, right? It encapsulated your best practices. It encapsulated, for this example, it encapsulated our best practices for building Docker files. But that same kind of method can be used to encapsulate your own best practices. And again, they're stored in source code. It's something that can be checked in and shared with your entire team. We saw containers play a big role here, right? That was what created the sandbox environment so that the error did not create a bigger blast radius. It also allows it to be very portable and easy to deploy at scale. We also saw that decomposition was really important, right? This seemingly simple task of generating a Docker file, a usable one, had to really be broken down into the sub-problems that have to be solved. That's whether that was the prompt itself, saying to first analyze the project and then generate the Docker file, but also the individual tools, right? The fact that there was a write files function and a scout recommendation function for the tag, or the analyze the project. You really have to decompose it into its parts. And then because of that decomposition, you've got a lot of different functions and services that need to interact with each other, and they fail. Reliability is going to be key to be able to make sure that that happens, the execution of that workflow happens in a reliable way. And when I put all these learnings together, and again, it's a simple example, but I think it's powerful. I think there's it's a really new type of architecture that we could be seeing built. And the way I frame this is, I think it's a little bit of a prediction that we're going to start seeing more non-deterministic architecture is being built, right? What I just showed was a bunch of disparate function calls and systems that didn't exactly have the deterministic logic set up on what to call when. The model was the one who was determining which function to call and even recovering when failure happened. And I really think this opens up new possibilities for us. So maybe it's automated testing, right? Instead of writing very deterministic and hard to maintain end-to-end test, maybe you can just have this kind of agentic workflow accomplish the goal of whatever the test case is without having to have a bunch of code written and maintained. Maybe the tools could have been written on the fly, right? I mean, the write files function is pretty simple. Maybe the tool could have actually automatically written that for you, the simple ones. And that would have been great for not having to predict all the cases that might need to be executed. Maybe you could even use this kind of architecture to avoid exceptions or bugs from the user's perspective. Imagine having the agent pre-execute the code, catch the exception, and then figure out a new code path to take so that it was successful all before it returned back to the user. I mean, you probably still want to fix the exception in the bug, but at least your user doesn't have the problem. And then maybe we can also use this architecture to coordinate various service calls based on whatever the user goal is, making new workflows possible without needing to actually deterministically code that workflow. So we're going to continue at Docker to explore this field and how better we can serve the application developers while they're getting started with GenAI development. It's one of our key focuses across the company. And we're going to continue to expand that footprint in different modes of application development, right? Whether that's powering the most popular GenAI platforms that you're getting your dependencies from, whether that's bringing you the most trusted content from open source, or whether that's expanding those catalogs to have all the different AI components that you might depend on, from models to inference engines to databases. So that's the talk. I'll put some links in here if you want to engage with some of this content that we walk through. At the top, you can see our AI Lab, the GenAI Lab series, if you want to engage with that. There's pretty much a new blog post that comes out every day that explores a new mission. You can also, in the middle there, get started with a out-of-the-box GenAI stack that helps you just get started with what it takes to build a RAG application. And then we always love engaging with our users on the community Slack channel, right? It's where you can engage with other Docker experts, but also with myself and everybody else at Docker. Thank you.